All right, you guys, this is going to be a review video for the AP exam. We're going to talk about binomial and geometric probabilities, and this video is intended for people who have already learned about this. So I'm going to skip over some of the details just to do a review and to remind you how to do the calculator commands. So write down these questions and their answers, and this is what you'll need to turn in class. So our scenario is about roulette. It's about a random person named Mr. Zheng who just happens to like to play roulette for its probability mainly. And the first setup is a binomial setup. And hopefully you remember what makes this binomial. The key here is that we know before we ever start that 10 spins are going to happen. That's the big distinction between binomial and geometric. Besides that, there are a lot of similarities as far as successes and failures and independence. So let's just list what we know. In this case, N is 10 trials. P is the probability of success. And on this roulette wheel, you can see I'm betting that it's going to land on 17, 5, 22, 34, or 15, which is this little section of the wheel right here. There are 36 numbers plus 0 and double 0. So we have 38 numbers total, and I'm betting on 5 of them. So 5 out of 38 is the probability that, I don't know why I said I mean Mr. Jones, who we're talking about. The probability that he succeeds is 5 out of 38. Now we could also define Q as 33 out of 38, the probability of failure. But in your calculator, we only have to plug in P, and then the calculator is smart enough to know what Q is because it's just 1 minus P. And then the rest of it, we have number of successes, and that's going to be specific to each question, A, B, C, or at least for A and B. Now, what makes, to officially be binomial, some things have to be true. We know the number of trials. We know each trial is independent, and the probability doesn't change. The marble doesn't remember where it's been. On spin number 2, I have the same chance of winning as I did on spin number 1. And the size of these 5 sections of the wheel are not changing, so I always have a 5 out of 38 chance. So let's skip right to it. Now there's a big formula that involves combinations and there's some exponents. Let's just do what you need to do on your test, all right? The command we want to use for the probability that Mr. Zheng wins exactly 3 times is binomial or binome PDF. PDF is for 1 at a time, probability density function. And the inputs are NPR, like the radio station. NPR, this is going to be 10 trials. The probability of success is 5 out of 38, and I'm asking about 3 times. Okay, a binomial can take any value. This is a random variable that can take any value from, in this case, 0 through 10. I might win 0 times. He might win once or twice. 3 times is the outcome that I'm looking for right now. So let's go to the calculator. This is under distributions, second bars, and it's down for me at option A, binomial PDF. 10 trials, 5 out of 38 chance of winning. Some of you would be tempted to put 5 divided by 38 into your calculator and round it off and get some decimal. That's okay, but why not use the exact value? Your final answer is going to be more exact. And I'm looking for 3. Now before, I like to kind of have an idea before I'm going in. I only have a 5 out of 38 shot, which isn't a great shot of winning. So winning 3 out of 10 seems to be pretty difficult. I'm probably not going to win 3 out of 10. So I'm kind of thinking this is going to be low, and that's just my thought process going in, so I kind of have an idea if I'm right. And it's not too bad. I mean, I have a 10, let's call it 0.1018. There's about a 10% chance that I will win 3 times out of the next 10 spins. All right, that's a straightforward binomial. All right, 2 or more. If we start to combine them together, we're going to want to use CDF. Now, 2 or more is saying this. These are all the possible values of my variable. I'm asking you to tell me the sum of all of those. So there's a couple options. You can do the PDF formula for 2 through 10, or we can do 0 and 1 and then subtract that from 1. Now, if I want to clump 0 and 1 together, here's what I'm going to do. 1 minus binomial CDF, 10, 5/38, and 1. CDF gives you the probability of that value, in this case 1, and all of the ones below it. And if I were looking for 1 or less, I would just do this CDF command. But since I'm looking for the rest of the possibilities, I need 1 minus that. All right, so you can just type that just like it looked. 1 minus distribution, binomial CDF, 10 trials, 5/38 probability of winning, and 1. So that's going to wrap up 1 and 0 in the same calculation, and then I'm going to subtract from 1. So I've got a, let's see, let's call that 0.3864. This is the likelihood that I win 2 or more times. Okay, and then finally, how many times do you expect him to win? Now, we had formulas for binomial and geometric for mean or expected value and standard deviation. Standard deviation on either one is not really, it doesn't have that much of a real-world application, but the expected or the mean is something you should know how to do, definitely. Expected value for binomial is very easy. It's n times p. All right, it's how many times I try times the probability of success. All right, so that's 10 times 5/38, which is 50/38, which is 1.3, let's call it 1.32. Now, I've told you at least 100 times in class, I know that I cannot actually win 1.32 times out of 10 spins. All right, I can win 0 or 1 or 2 or 3, all the way up to 10. Most of the time, I'm going to win probably 0, 1, 2, or 3. And then the percentages start to drop off very heavily after that. But on average, if everybody in the room played 10 times with this same strategy, on average, they would win 1.32 times. Or if Mr. Young went every day of the year and played 10 times and wrote down how many times he won, it would average out to 1.32 times. All right, the expected values don't have to make sense in the real world, as in discrete values can be continuous with expected value. Let's change tunes to geometric. If Mr. Young has a different strategy, he's going to go play until he wins with this betting strategy, until he wins on the 5/38 chance. This is geometric. The difference being, I don't know how many spins I'm going to take. All I know is that I'm going until I succeed. All right? That's what makes it geometric. Now, the similarities, the differences are n is what I do not know. I don't know how many times I'm going to try. But p is still 5/38. Q is still 33/38. I still have independent trials. I still don't change my probability from one to the next. But I'm just asking a different question. All right? This is a straightforward one. What's the probability that my first win is on the 5th spin? Now, you can do this in your calculator with the geometric PDF and CDF. I think it's easier to do these by hand. All right, if I'm going to win on my first try, that means I failed if I'm going to win on my 5th try, that means I failed 4 times. So the formula here is Q to the n minus 1 times P. This is the probability that I succeed on the nth trial. Let's sum that up. The probability of the nth trial, Q to the n minus 1 times P. Because think about it, if he's going to win on the 5th try, that means he lost, which was 33/38. And then he lost again and again and again. He did that 4 times, so I'm going to raise it to the 4th power. And then he succeeded. Okay? So in my opinion, I'm just going to write down that equation and kind of do this one by hand. 33/38 to the 4th times 5/38. This is the probability that he succeeds for the first time on the 5th. So that's 0.0748, about a 7.5% chance. All right. So that's a pretty straightforward geometric. Fail, 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 succeed. All right. What is the probability that his first win is after the 7th spin? So what's going on here is there's an infinite amount of possibilities. And we talked about how the first try is always the most likely. Even if it's an unlikely success, one trial is your most likely in geometric. Then we take a percentage of that and a percentage of that by adding in another fail each time. And this goes on forever. So there's infinitely many bars. What I'm asking you is the sum of the 8th, 9th, 10th, 11th, all the way out to the infinity bars. So luckily, there's a little way to sum this up. The probability that we succeed after the 7th try means we had to fail 7 times. So all you have to do here is q to the 7th. All right, this is actually easier. It's more difficult to understand, but it's easier to figure out. If I want to know the probability that the success is going to happen, it's going to take me 8 or 9 or 10 tries. The one thing that's constant in all those different possible outcomes is the first 7 failures. All of the other branches of the tree combine to form what would happen after these 7 failures, but we don't even have to consider that. All we have to do is q to the 7th. So 33/38 to the 7th for 7 failures, 0.3725. Chances, the likelihood that it's going to take more than 7 spins in order to succeed. And finally, how many times do we expect him to play until he wins? If I have a 25% chance of success, in the long run, I'm going to average out to, which is 1 out of 4. It's going to take me on average 4 tries. If I have a 1 out of 10 shot, it's going to take me on average 10 tries to succeed. All I'm doing is flipping over or taking the inverse of the probability. All right, so mu for geometric is 1 over p. And for us, that's 1 over 5/38, which means on average it's going to take me 38/5 tries in order to succeed. So let's see, 38/5, 5 goes into 35 7 times, 3 left over. It's going to be 7.6, I believe. Forgive me if I did that wrong, but I think that's good. And again, I understand I cannot try 7.6 times, but I might win on the first try, or the second, or the 88th. All of those, if I sit there all day for the rest of my, or not all day, every day for the rest of my life, it will average out to 7.6 trials. So that's it. That's our crash course review of binomials and geometrics. You're more of a calculator person. Let's try that that first question with the calculator. I'll take that back. Let's do geometric PDF. Let me pause and make sure I know the commands. So if you want to do geometric in the calculator, which is more difficult in my idea, in my mind, geometric PDF, like that first one we did, what's the probability that the success was going to happen on the 5th spin? You put the probability first, and then the number of spins, and you get the 0.0748 that we had earlier. I think, again, it's easier just to do that one with this formula, just set it up and multiply it. If you do the other one, you have to remember the difference in the 2 calculator commands, and that just confuses things. I remember binomials are NPR because of the radio station, and this one is better just to do by hand. All right, so that wraps it up. Bring these notes to class. I'll see you there. It's one of many topics we're going to review, binomial and geometric. So you can get that 5 on the AP test. Cinco. Out.